As we are working with functions, the word problems we have come across are asking you to find the constant rate of change and the initial value. There are nothing else but the slope that we have been working on and the y-intercept. So let's review those concepts so it's easy to solve the function problems. How to find the constant rate of change or the slope. We are going to be looking at the graphs, the equations, and tables. For the constant rate of change or the slope, when a graph is given, I need 2 points. Let's start with this point right here, 1 and 7, and this point right there, 2 and 9. All right? Now, please make sure as you are working that the intervals of x-axis and the y-axis, if they go by ones or go by twos, by fours, whatever it is, because not always they will go by ones. So let's take a look at this point. Find the slope or the constant rate of change. I'm going to count the rise over run. Okay, so these are going by 1, so I'm here at 7 right here. So I go up 1 to 8, another 1 to 9, so I went up 2. And then from this point, I'm right here on 1, so I'm going to go to 2. So from 1 to 2, the run is 1. So the slope is 2, the rise, over 1, the run. So if you can get a whole number out of this, 2 over 1 equals 2, so express that as a whole number. For the y-intercept, I'm going to be looking at a point where the line crosses this y-axis. So let me take a look at it. It's the point right here where the line crosses the y-axis. That is the y-intercept or the initial value. And we express that with the letter B, which is 5. So that's the y-intercept, or the initial value. Both say this, mean the same thing. All right, let's take a look at this other graph. I'm going to be looking for the y-intercept. I'm going to be looking for the slope. Let's start with the y-intercept this time because it's easy to see. It's right there. The y-axis is being intersected at this point, -2. So the y-intercept is -2. That means the initial value is 2. What that means is when x is 0, the y is -2. Okay, now let's find the slope. I need 2 points for the slope. Notice how on the y-axis, it goes by 2's. You see that? And then on the x-axis, it goes by 1. So be very careful when you count the rise over run. I'm going to use these 2 points, okay? Now, to go down from 2 to this point right there, going down, that is -2 because I went from 2 to 0, from 2 to 0. That's -2, all right? Then going right, 1, 2, and then the run was 2. And I can tell that the slope is negative because from left to right, the line is going down. So the slope is -2 over 2, which equals -1. That means the constant rate of change is -1. It's being decreased by 1, all right? And the initial value was -2. Let's take a look at equations now. For you to be able to tell what the constant rate of change and the initial value are here, you need to remember that formula, y equals mx plus b. When m is the slope, or the constant rate of change, and b was the y-intercept, or the initial value. So looking at these equations, all right, the number mx, the number attached to the x is the slope. So in this case, m is -4. So the constant rate of change is -4. And b, the y-intercept or the initial value, is 3. All right. Looking at this other equation, the constant rate of change or the slope is 2/5, and b, the initial value, is -2. It's right there to see, all right? Let's take a look at the tables. For the tables, we have to do just a little bit more work. For the initial value b, it's going to be pretty easy. For both tables, I can do that right away. For the initial value, we are looking for that point when x is 0. What is the y? All right, when x is 0, what is the y? So the first coordinate is 0. What's the value of y? Looking at the table right there, when x is 0, the y is 8. That means that the y-intercept or the initial value is 8. For this other table right here, when x is 0, y is 10. So the initial value is 10. All right? That's how easy it is to find the y-intercept. Now let's find the slope. For the slope, we need to find the change between the x's. So the slope will be delta y over delta x. Remember the formula y2 minus y1 over x2 minus x1. That's what it means. You are basically comparing, you are actually finding the ratio of the difference in y's over the difference of two x's. So we know that these are functions, the differences are the same. So it goes up by 1, up by 1, up by 1. And here also it goes up by 1, 9 to 10, up by 1, up by 1. So the difference in y's, in two y's, is 1. And the difference between the two x's is also 1. So the slope for that table is 1 over 1, or simply 1. Now let's find the slope for this other table. From -4 to -2, it goes up by 2. From -2 to 0, it went up by 2. 0 to 2, it went up by 2, and so on. All right? So if I'm looking to find the slope, the difference between the two x's is 2, positive 2. Now the difference between the y's, from 4 to 7, it went up by 3. 7 to 10 by 3, and so on. So the difference between the two y's is 3. The slope is 3/2 or 1/5. Because we're talking about the constant rate of change, at times you would have to use decimals to show that change. Okay? This is how you find the constant rate of change and the y-intercept from these three representations. Now let's apply what we just reviewed. Function a and b are linear functions. Which function has a greater rate of change? So they are asking you for that slope, okay? Looking at the table, I'm going to find the rate of change by finding the difference between the two y's, because the difference between the y's is they are given, it says there it's a function, so we know that from one number to another, it's going to be a constant, over difference between the x's, okay? So let's pick these 2 points because they're easy. From 5 to 10, the difference between these two x's is 5, positive 5. From 7 to 12, the difference is positive 5, okay? So the slope for this is 5 over 5, which is 1. I found the rate of change for function A. Let's find the rate of change for function B. For this one, I need to find rise over run, okay? So I'm going to pick 2 points. Let me pick this point right there and this point there. Make sure that they go by ones. All right. Make sure to check the interval of the graph. So it seems like each box represents 1 unit. So going up 1, 2, 3, 4, 5 over 1. So 5 over 1. The slope is rise 5, run 1, which equals 5. Function B has the greater rate of change, which is 5. The other one had it as 1. All right, let's take a look at this other problem. 2 linear functions are shown. Which function has a greater initial value? All right, so if they're talking about the initial value, they are talking about the y-intercept. Y-intercept. Okay? They are talking about that b. And remember, for the equation in the form of y equals mx plus b, b is this 5 right there. So initial value, b, is 5. For the function b, I'm going to go to that value where x is 0. When x is 0, all right, the y is 8. The y-intercept, or the b, is 8. So b is 8 for that. Which function has the greater initial value? Function b has a greater initial value. This is it. Please let me know if you have any questions.